in the model question paper discussion for the subject digital system design using Verilog. So in this session, you will be able to understand what are all the important questions which you can prepare for the forthcoming examination. As you can observe, we have the course code of BEC 302 and the teaching hours, then total teaching hours of pedagogy, then credits or credit subjects, semester, third semester, 50 marks for CIE and 50 marks for SCE, and the total marks will be for 100, and the university examination will be having 3 hours. So this is regarding the basic information about the subject. And the questions you can familiar. The question paper have 10 questions, and each question is set of 20 marks. There will be 2 questions from each module. Each of the 2 questions under a module with a maximum of 3 sub-questions should have a mix of topics. Okay, so remember that you don't focus only for 1 or 2 modules. You try to cover all the modules. The students have to answer 5 full questions, selecting full question from each module. That also you have to be very much careful. Try to attempt all the questions. Marks scored by the students shall be proportionally scaled down to 50 marks. So that 50 marks from the university examination, another 50 marks from the internals. Okay. So 50 plus 50, total 100 marks will be getting. So the first module we can see the principle of combinational logic. These are the major topics which are comes under module 1. Here you can see the important questions like to design a logic circuit that has 4 inputs. The output will be only be high when the majority of the inputs are high. Use K-map just for the K-map simplification. So another question is question number 1B, that is McCluskey by using the McCluskey technique you have to solve this particular function. This function you are supposed to solve, which has the weightage of 10 marks. Question number 2A, simplify the following expression using K-map. Implement the simplified expression. Okay, try to do the like a K-map. DC, that is non-cap terms. You mark accordingly, and like a grouping should be done. Based on the grouping, you have to simplify. Define the following terms with example: min term and max term. Okay, so you can like divide the marks like 2 plus 2. Place the following equations into proper canonical forms. You might have studied about like a SOP, POS, sum of product or sum, and you need to know how to write, how to express these function into canonical form. So which is the weightage of 6 marks. From this, I will be giving one tip which is more convenient. Try to attempt first. Then regarding the module 2, logic design with the MSI components and the PLC, programmable logic devices. So in this you will be learning about binary adders, subtractors, comparators, decoders, encoders, mugs, then PLDCs. Okay. So textbook also they have mentioned directly here. Probable questions like module 2, design 2-bit magnitude comparator, write the truth table relevant expression using the logic diagram. Okay, so you need to know the comparator. What comparator does? 3 conditions you have to mention. One is less than or equal to, greater than or is equal to, then equal to. Then implement the following function using 3 is to a decoder. You should know what is a decoder, how to develop the decoder corresponding the function. Then implement y is equal to AD plus BC dash plus BD using 4 is to 1 multiplexer considering A and B as a select line. Okay, so here you have to mention multiplexer means many input, one input. You need to consider the selector line as well. The total weightage is 20 marks. Okay. Question number 4a, explain four-bit carry look ahead adder with the need diagram and the relevant expression. Okay, which has the weightage of 10 marks. Try to mention the lookup table. Later, you have to convert the lookup table into logic diagram. Implement the following Boolean function using 8 is to 1 multiplexer and 4 is to 1 multiplexer for the given function. Okay, so 5 plus 5, total 10 marks you will be getting. Moving on to the third module, it is on flip-flops and its application. You should know about the basics of flip-flop, SR flip-flop, JK flip-flop, then characteristics equation, registers, then shift register, binary ripple counter, then synchronous binary counters, then shift register, synchronous mode and counter, up counter as well as down counter. Okay, these are the basic information you should know about regarding the flip-flop and its application. Explain the working of master slave JK flip-flop with the functional table and timing diagram. Okay, so weightage is 10 marks. Even try to write down the equations as well. Explain the universal shift register with the help of logic diagram with the control table, which has the weightage of 10 marks. Derive the characteristic equation for SR, T, D, and JK flip-flop with the help of function table. So each flip-flop you are supposed to explain why we have to go for SR, then T, D, JK, etc. So you have to mention about each truth table with a suitable diagram and equations. Design the synchronous mode 6 counter using SR flip-flop for the sequence 0, 2, 3, 6, 5, 1. So first of all, you have to make the table. From that, you have to draw the logic diagram. Then you can follow the sequence, which has the weightage of 10 marks. Module 4 includes introduction to Verilog and Verilog data flow description. First question number 7, realize two by one multiplexer with the active low enabled, and also write the Verilog program by considering delay time to the signal assignment statement with the simulation waveforms, which carries 10 marks. Realize the full subtractor circuit using Verilog data flow description, which has a weightage of 10 marks. Question number 8, list all the data type available in Verilog STL and explain any four data type with examples. Theoretical part, which has the weightage of 10 marks. So preparation of the list carries 4 marks, explanation of four data type carries 6 marks. Then explain the arithmetic and logic operator with example. Okay, 5 plus 5. Arithmetic operators 5 marks, logic operators 5 marks. Question number 5, Verilog behavior description and Verilog structure description. 9a, realize the D-latch behavioral description code with a diagram and waveforms. Write the Verilog structure code for with ripple carry adder. Theoretical based, you will be getting, you can score full marks. Explain with the syntax of the following sequential statement. Verilog, for loop, while loop, repeat forever. So total like 4 marks, like 2 plus 2 plus 2 plus 4, like that it can be, or 2 into 4, 8 marks. Write a Verilog program for 8:1 marks using case statements. Weightage is 6 marks. You might have done it in like a laboratory. Realize the JK flip-flop using Verilog behavioral description, 6 marks. Try to go through some like a programming exercise they might have given at the end of the syllabus. Kindly go through that. So obviously that will help you to write the code effectively. So thank you for watching this video. I wish you all the very best for your examination. Let me know if you have any queries. I will make a separate like a link for giving the suitable solution for this particular question. You can watch afterwards. Link is available in the description box. Kindly check it up. So thank you for watching the video. Have a great day. Happy learning.